channel. So in this video we are going to learn about network software components. So in the previous video we have discussed about the network hardware components, that is the transmission technology and scaling techniques. So now we will see how the transfer of data will take place between two devices in the software components. So first component is system. So system is a collection of layers. So here a system is a computer, right? So a device consists of a number of layers for communication. So normally we will be using OSI model and TCP/IP model. So we are having two types of models for communication. Okay, OSI model and TCP/IP model. So TCP/IP model is used mostly compared to the OSI model. Okay. So in the OSI model we are having 7 layers, whereas the TCP/IP model we are having 5 layers. So next one is the layer. So it is an active element in a system. So layer is an active element in a system. So we are having sender 1 and system 1 and system 2. Okay. So an active element in a system is called a layer. So we are having 5 layers in the given device. The next one is the interface. Interface means the relationship between two adjacent layers within the system is called interface. Okay, so the relation between two entities within the system. So in the system 1, so within the two layers, the relation between the L5 and L4 will be, the communication between these two layers is done through the interface. Similarly, the communication between L4 and L3 is done through the interface. So interface gives a relationship between the adjacent layers within the system. So next one is the protocol. Protocol is used to establish a virtual communication between two layers which are existed on two different systems. So we know that protocol means it will be having set of rules that support communication between two devices. Right. So here a protocol will establish a virtual communication between two layers of different systems. Okay. So here the protocol is establishing communication between the layer 1 of system 1 and layer 2 and layer 1 of the system 2. Similarly, the protocol is establishing communication between the layer 2 and in the system 1 and layer 2 in the system 2, and so on. Okay. So next one is the protocol stack. It is a collection of the protocols. So here the protocol stack has a collection of protocols, that is the protocol between the layers in the different system. And next one is an entity. An entity is an active element in a layer. So in each layer it supports different protocols. Suppose if you consider the network layer, it supports IGMP protocol, IP protocol, TCP/IP protocol. So at a particular time in a layer, any one of the protocol may be active. So next one is the peer entity. Common active elements in two layers which are existed on two different systems. So next one is the peer entity. Common active elements in two layers which are existed on two different systems. Okay. So here the transfer of data flows from one layer to another layer in a system such that they communicate with another peers in the different system. Okay. So here the common active elements in two layers which are existed on two different systems. So here suppose L2 is the active system in the different two systems. Okay. So now the communication will be between the sender, system 1 and system 2 will be such that these two are communicating with each other, directly communicating with each other. But actually the communication starts from the system 1 from the top down, that is from L5, L4, L3, L2 and L1. So here the L5 is the application layer which is which interacts with the user, and the data is passed through the below layers to the lower level layers. Okay, so next the data will be transmitted through the transmission medium, and then the data passed from the low level layers to the higher level layers. Okay, so here the peer-to-peer entity means the data is transferred to the from system 1 to system 2, from top down and the bottom up. But the data will we will assume that the communication will be in such a form that the data is actually transmitted from this peer in the system 1 to the peer L2 in the system 2. Okay, so that's why it is called as a peer-to-peer entity. So this is the basic network architecture. There is a collection of layers, entities, interfaces, peer entities, and protocols. So protocols means set of rules that support the communication between two devices, and we are having the OSI model is having 7 layers, and the TCP/IP model is having 5 layers. And the entity means an active element, an active layer in the given system is called as entity, and interface means relationship between the neighboring layers, the adjacent layers is called as the interface. So now we will see what is meant by data transmission. So at the sender side, the data transmission will be in the top-down approach, whereas at the receiver side it will be bottom-up approach, as we discussed earlier. So here at sender side, the data transfer will be in the top-down approach, whereas in the receiver side, that is sender to the system 2, it will be in the bottom-up approach. So in data transmission, every layer has a message format, that is address and data format. The message format will be in this, that is from address and data format. Okay, so except in the data link layer. So in the data link layer, we will be having it will be in the given format, that is the header, data, and trailer. So this is header format, trailer, and the data. So the trailer will be having the error detection and correction techniques, whereas the header consists of the address field, and the D means it consists of the data field. So in data transmission, every layer has a message format, that is address and data, that is header and data format. But only in the data link layer there will be a trailer, but in the remaining layers, so it will be in the format of address and data, that is the header and data format. At sender, during the transmission, headers are included and encapsulation process takes place. Okay. So coming to the encapsulation. What is the encapsulation? It is the process of inserting message format into another message format's data field. So we know that network layer, in the network layer, the data will be in the format of packets, whereas in the data link layer, it will be in the format of frames, and in the physical layer, it will be in the format of binary bits. Okay. So here at each layer, the message format will be in a different format, right? So we are encapsulating the packets into frames and frames into bits. So encapsulation means it is the process of inserting one message format into another message format, right? So in the network layer, it will be in the format of packets, and in the data link layer, so we are again converting it into a format of frames, and in physical layer, it will be in the format of binary bits. So for example, you can consider the encapsulation as in the real-time example. Suppose I ordered a mobile phone through the Flipkart. Then so what they won't send the mobile phone directly to your home, right? So they will pack that mobile phone in a box, and then they will wrap the given mobile phone in a normal box, and then again they will encapsulate that box into another box for delivering right into your home. So in this way, the encapsulation process takes place. So this is one of the Real-time example. At the receiver side, during the data transmission, headers are excluded and decapsulation takes place. So at the receiver side, after getting the information, okay, so the headers consist of the source and destination address, right?